Okay, let's get to some good intellectual meat here. Everything is an object, every operation is a method call. This is, for me, kind of what disentangled the language for me, and I hope it will do the same for you. Okay, so what does this mean? Everything, even the lowliest integer, is a true object. That means that you can ask an integer like 57 what methods it responds to. 57.methods will actually return a list of all of the things 57 could do if you asked it to. Heinz varieties isn't one of them, but I was trying to make a joke there. Probably your grandparents would have got that joke. Even nil, which is just a constant that means false, can answer questions about itself. You can ask if nil would respond to the method toS, which converts it to a string, and indeed it would respond true. Yes, I can respond to that method. And in fact, once you realize this, you realize that in fact everything in the language is just syntactic sugar for doing a method call. So send is the sort of language primitive that means send this message or this method call to this object, right? So Meister.length means, whoops, there we go. Meister.length really means Meister.send, right? Send is defined on every object. And I'm going to send Meister the method name length, and hopefully Meister will be able to do something sensible, like run that method if it has one. So what does this mean? All of these things that look like operators and that look like they're part of the language really aren't part of the language. Right? This is really just syntactic sugar for sending the plus operator plus the single argument 2 to the object 1. When you dereference an array, well, you're just sending the method bracket dereference, which is a real method name, and you're sending the argument 4 as an additional argument to that. What about when you assign something? Assignment is a method call, right? Assignment is not really assignment, it's a method call. So there is a method bracket equals, which is what myArray implements when you try to set an element, like the third element, to a particular value like foo. Even comparisons, right? I'm sending the equality comparison operator to 3, I'm sending the equality comparison operator to x with the additional argument 3, which, by the way, this should, if you're super awake, this should say, wait a minute, you mean, suppose I wrote if 3 double equals x, you mean that might actually call a different method than when I write if x double equals 3? And indeed, the answer to that question is yes. Right? The receiver is the one on the left-hand side, and it decides how it's going to implement that method. So we're going to see some ramifications of this in a minute. But the idea that in some languages there's things like implicit conversion, right? If you compare two items, and let's say one of them is an int and one of them is a float, and there's all these rules about who gets converted to what. In Ruby, it's much simpler. Whoever the receiver of the method is decides what to do with the method. And if they decide to do something stupid, then that's the way the cookie crumbles. So things like comparison and casting are not in the type system, right? They're entirely in the way the instance methods are implemented. And lastly, if I just call myfunc without any explicit receiver, in other words, there's no dot in front of it, who's going to receive this? Well, because Ruby is purely object-oriented, at every instant of time, self refers to something, right? Self, which is like this in Java, it means this object, who I am right now. Wherever you are, it's got an implicit value. So if you leave it out, Ruby will just use whatever the value of self is and try to send the method call to it, and hopefully it'll work, and it'll be what you intended. So what does this mean? It means, remember the Pavlovian bell, right? When you see a.b, it always means you're calling method b on object A. It doesn't mean that b is an instance variable of A. It doesn't mean that A is some kind of data structure and b is a member. If you remember this, it'll save you much grief and confusion. And the reason I want to burn this into your little brains is because there is, in fact, notation when we do object-oriented programming in a moment where it looks a whole lot like a.b means you're referencing an instance variable. And you sort of are, but this is the way it's really implemented, right? And if you remember this, you can't go wrong. OK, what else does it mean that every operation is a method call? Well, here's a few more examples. Why is it that I could say, if y is an array, how come I can apply the plus operator to arrays? OK, so now, as you know, when you go to your Ruby book and look it up, you're not going to look for some section on what happens if you try to cast an array using plus or overload the operator. No, you're just going to look in the array class and ask, does the array class implement the method plus? And if so, what does it try to do? As it turns out, what it does is concatenate the arrays, which is kind of what you would expect. It also supports the double less than operator, which you've probably seen in other languages. However, this is a good example of an operator that destructively modifies its receiver. Okay, so this is an important distinction. The vast majority of Ruby methods create a copy of the receiver, right? If if I didn't have this left-hand side, if I just said y plus another array, a new object would be created, which is the concatenation of y and this foo bar array. But when I use the double less than operator, I'm actually destructively modifying the receiver, right? So there's a very few of them that do this. But again, keep in mind these are all instance methods of array. These are not part of the language, right? They're not language operators. So again, just to drill it in a little further, here's 3 different expressions that all use the plus sign, right? These are all calling different methods. There's no casting going on here. It's just that in the first example, we're calling the instance method plus defined in the numeric class. And by the way, the pound notation means instance method. In the middle example, a plus b, we're calling the plus method as defined in string. And in the last example, it's the plus method as defined in array. There are 3 different methods. They happen to have the same name because kind of this is what you would expect if you were looking at the code. OK, poetry mode. So a pervasive idiom in Ruby is that there are cases when it's legal to omit braces around hashes or parentheses around arguments. And basically, it happens whenever the parsing would be unambiguous. The most common features that you'll see this used for is when a method is defined to take a hash as its last argument. Right, so in this case, here's an example down here. We have a method that takes 2 arguments. The first one's a string. The second one is a hash. In this case, because the last argument is a hash, it's syntactically unambiguous to omit the braces. So we could take those out. And in fact, because there's nothing following this function call, it's actually legal to also omit the parens around the method arguments. So the bottom form is how you'll often see it written. And although it seems confusing when you first come across it, once you get used to the lack of clutter, it's actually really nice. You'll find that parentheses become like a barrier that your brain bumps into as you're scanning code, and not having them in the way, you'll come to appreciate it. As with all features, when in doubt, parenthesize defensively, and usually the interpreter will tell you if you've done something where the parse is ambiguous. Obviously, if you have a function with 2 hashes, you can't really use this feature because you need a way to tell where one hash begins and the other one ends. Yes? I think it just got chopped up. Yeah, the comment was that there's no closed paren on this first one. There is on my screen, but I think it just got chopped off a little. But yes, there should have been a closed parentheses around this first line. OK, poetry mode in action. Here's a little preview of readable code. Here's an example of combining poetry mode and syntactic sugar to make. We think beautiful code is really important, right? And what does beauty mean? You don't write code for the computer. You write code for other humans who are going to come after you and maintain it. So here's a way of asserting that a particular variable should have a value greater than or equal to 7. And we're going to sort of deconstruct this to show why poetry mode is a cool thing. So this is really easy to parse, right? Should is a method call on the receiver A. And what is the argument to should? Well, it's this other expression, B. Well, turns out B is a method call. We've just omitted the parens because there's no arguments. And on the result of that method call, we're going to call the send method on B, and we're going to send it 2 arguments, the greater than or equal to operator and a number. If we sugar this down a little bit, well, we know that x greater than or equal to y is just syntactic sugar for x send greater than or equal to with y. So we could rewrite this way. And by taking advantage of the fact that parens are optional if they're unambiguous, we could just write that. So there's this example at the beginning of the book that says this line is legal Ruby. This is the reason why it's legal Ruby. Now, you could take 2 points of view on this. One point of view is you could say, this is syntactic sugar tricks, and it's cute, but it's not really useful in the long run. The other is you could think, if I'm spending 6 hours a day reading test code, which one would I prefer to be reading? So we obviously take the latter view. Oh, the question is, what's the colon here? Because the first argument to send is the name of the method that you're trying to send to the object. As it turns out, I could have put this in quotes too. But all of the examples that I had with send, the first argument is a method name. And idiomatically, usually you send a symbol for the method name. Yes?
Why do you have just the 2 braces right after the B in the second line?
Why are there?
Yeah, why is it there at all?
So the question is, why are these empty parens after B? It's to make explicit the fact that B is actually not a variable, it's a method call, right? It's just that in this top line, you can't tell offhand that it's a method call because you don't see the parens. But I could have put the parens in the top one, too. That would have been legal. Probably would have been a little clearer as well. Yeah?
What is B a method call of?
The implicit so the question is, what is B a method call of? What is the receiver of B? Without getting into too much detail, It is an instance of an expectation matcher, which is a thing in the testing framework that accepts a condition to be evaluated later, so that you can essentially set up conditions in your test saying, after I do something, this variable should have this value. So what actually happens is you're setting up the condition, then you're going to run some code, and later you're going to trigger that condition to be evaluated, and that's what B is an instance method of. It's the expectation matcher. We'll see a lot more of this in Chapter 4. It is super cool. OK. You can tell I get excited about this stuff easily. Again, syntactic sugar mode. Here's a page from an app I wrote a few years ago. You can kind of get the sense of what it does just by looking at it, right? If you're not logged in, it should redirect you to the logging page and return from the current method. Or you could write it that way. Again, big deal, you can eliminate parentheses. But when you can read code and just kind of read it like it was a description of what the code is supposed to do, that's better than having comments.